In the last video, we talked about how we can neutralize all the new buildings that come onto this campus so that they don't continue to add a carbon burden to our existing buildings. As we know, we have a lot of existing buildings, and it's going to be very difficult for us to bring those down to zero as well. So, in order to neutralize the new buildings, we talked about the embodied carbon and operational carbon. So, in this video, we'll look at our strategy for the embodied carbon. So, as you remember from an earlier video, the life cycle stages really go from the very beginning of a product all the way to the very end use. For us right now, we'll just be looking at these first three: the extraction and refining, the manufacturing, and the installation. And for the construction process, it looks a little bit more like this graphic, where we have a lot of heavy industrial energy that goes into the creation of concrete and steel, for example. And then on site, we have big equipment like cranes and moving dirt moving equipment. In our action plan, we have stipulated that the cost for offsetting embodied carbon must come from the capital budget. And there's two reasons for this. Number one, if it doesn't come from the capital budget, then where will it come from? If it doesn't come from the capital budget, it would mean that the rest of the campus will have to subsidize these new buildings. That's not fair. It means that people would be taking money out of their own research agendas so that they could contribute to this new building. The buildings need to be able to stand on their own. But number two, the second reason is because we want an incentive for the design teams to shrink that embodied carbon as much as possible so they have more budget to work with. So let's take a look at it this way. Imagine that we have a new capital project and the budget is $100 million. And the estimate for paying down the embodied carbon is 2 million. Well, that means that effectively the design team has a $98 million budget, not 100. But if the design team can develop creative means for avoiding carbon and the embodied carbon, well, then there's more money to work with. And that's what I think we all want. That's a win win. So, embodied carbon for us includes both the carbon from the life cycle stages of product materials and equipment. For us, mainly that's concrete and steel, but of course, there's other things as well. But those are the dominant two. And then, secondly, the emissions resulting from the construction process. So, that's the use of large machinery. And the emissions from the construction process have to be included in the embodied carbon calculations. So the action plan stipulates this performance target. The maximum amount of embodied carbon shall be 500 kilograms of CO2 equivalent per square meter of construction floor area for the superstructure portion, that's stages A1 through A3, as well as the construction process, that's stages A4 through A5. Now, this sounds very aggressive, and it is, but it is aligned with our latest new construction projects. So we know it's possible. It's a challenge, but we know it's possible. We want that to be our baseline, and we hope to do even better than that. Okay, now, one thing that we should note is that we recognize that the LCA databases are still developing. We feel like there's good information on concrete and steel and some other core and shell materials, so that we can get good data on how much embodied carbon is available in those options. But we also know that for many of the other things, that's just simply not available yet. So our action plan says that from now until 2030, then embodied carbon calculations must include the core building and the shell. So that's the superstructure, glazing, cladding, and wiring. Starting in 2031 through 2035, we will continue to include the core and shell, but at that point, we'll start to include the MEC equipment and then selected finishes. And by 2035 onward, we assume that the databases should be sufficient to cover everything within the building. So that would include all of those above, and interior and exterior finishes. Now, calculating the embodied carbon can be a bit tricky, but we have developed a couple of tools that are available for all design teams to use, and we use them and we encourage the design teams to use them as well. Here's a snapshot of one of the ones that we have that can help with embodied carbon. In a future video, we'll go into these tools more specifically so I can show how to use them and how they can be as much benefit. Okay, in the next video, we'll talk more about the operational carbon and how that will affect the design process.